everyone, and welcome back to physics class. Today, we are going to review some basics when it comes to problem solving, particularly when it comes to algebra and performing literal calculations. So, what do I mean by literal calculations? So, a literal calculation involves a calculation that only uses letters, essentially. It just uses variables. There are no numbers involved. It's just variables and letters. You still need to follow the same rules as with regular calculations when you're doing these literal calculations. So the rules of multiplication, division, addition, and subtraction, all of that applies. Literal calculations are used to isolate for variables in complex problems. So we're going to be seeing a lot of complex formulas that have very different variables associated with them. And you're going to be expected to be able to isolate different variables from different equations. So let's try an example. We've been given this formula right here. So we have V is equal to delta X over delta T. So first of all, what do these mean? Well, V stands for velocity. This delta X is our change in position, also called our displacement. And delta T is our time. It's specifically our change in time. So we want to isolate for time in this formula. How do we do that? Well, let's go ahead and take a look at what's happening here. So we have velocity is equal to delta X being divided by delta T. We want delta T to be isolated completely. So this means that we eventually want to get to a part where delta T is equal to something. But how do we get there? Well, the first thing we want to do is we actually want to get rid of delta T as the denominator in this fraction. We want it to be a numerator. We don't want it to be on the bottom of the fraction. So to do so, we are going to multiply this whole thing by delta T. And we're also going to do the same thing to the other side. So whatever you do to one side of the equation, you have to do to the other. So delta T is being multiplied with my V on the side. Here, you will notice that if we were to multiply this out, we would get V delta T is equal to delta X times delta T over delta T. Now, here we have this very interesting thing. We can actually cancel these two delta T's. Why? Well, what's delta T divided by delta T? We'll give you 1. So it's the same thing as saying delta X times 1. So we can just get rid of these delta T's. We can cancel them out. And it will just become V delta T is equal to delta X. Now I need to make some space here, so let's erase these things here for now. So we have delta X isolated, but we want to isolate for delta T. So we have to do one more step. And that step will be to move this velocity. So how do we move this velocity? Well, right now, velocity is multiplying delta T. We want to do the opposite of multiply. So the opposite of multiply is to divide. So I'm going to divide both sides by my V. And these V's will cancel out. And then I will be left with delta T is equal to delta X divided by my V. Now, this is a simple literal calculation. You'll be expected to do a little bit more complex things in this class, But this kind of shows you how you can manipulate these different variables to fit what you're looking for. And this is very important, especially when it comes to manipulating units. So let's look at an example of unit. Scientific calculations need to consider the units as part of the calculation. Since units are expressed as letters, literal calculations need to be applied to these units. If we've been given the velocity, we need to calculate the time it will take for an object to travel a certain distance. Now, just as a reminder, we had already isolated our delta t in the previous example. We have been given some information. We've been given our velocity, and we have also been given our delta x. So let's plug our numbers into our formula. So delta t is equal to 175. And don't forget, you have to put in your unit here, which is meters. And we're dividing this by 15 meters per second. So first thing we want to do is we actually want to do this division. So let me just pull up my calculator here. 175 divided by 15 will give me 11.6 repeating. So I'm going to just round that up to 11.7 just for now. But I need to take a look at my units. So I'm just going to keep my units as is right now. So I have meters over meters per second. This looks a little funky. So let's see if we can simplify this a little bit. We have meters divided by meters per second. We can also write this out in a different way. We can just say meters is being divided by meters per second. We have a fraction here, and technically we could have this as a fraction too. We just put this over 1. We have to remember our rules for dividing fractions. So if we divide fractions, the first thing we need to do is we need to take the reciprocal of this one right here. So that means that we are going to flip it. It's going to become meters, and then this is going to become seconds over meters, like that. So this is my reciprocal. Once I've taken my reciprocal, I'm going to change my division to a times. And then I'm going to see that my meters will actually cancel out. And then I'm just left with seconds. So my time is 11.7 seconds. And that's how you manipulate your units. I hope this was helpful to you. I will see you all next time. Bye.